Welcome to an AP Human Geography video on Introduction to Maps. So we're going to be getting into AP Human Geography. This is the first topic and lesson of AP Human, and we're going to be getting into maps. And we're going to be looking at spatial patterns and how to read maps and all of that fun stuff. And then in the next video, we're going to be getting into geographic data and technologies and all that stuff. And we're going to show that geography is a lot more than maps. But this video, we're just going to focus on maps. So what are the different types of maps? Well, the first is our reference map, and we are referencing where something is. So here we have a reference map of Australia. Political maps are reference maps. We see the boundaries on our map. We can also have toponyms, which are just place names, technically. Um, so we can commonly see these on reference maps. And what's on reference maps is qualitative data. And this data does not deal with numbers, it deals with the quality of some place. So an example of qualitative data is on this map is going to be our um, topography, which is just like our physical features. So I put an arrow towards Mount Everest, which is a physical feature. Topography is physical features. Some other physical features could be the Tibetan Plateau. This is not labeled. I don't see it labeled anywhere. It could also be the Pacific Ocean, as well. So yeah, those are two other things in topography. But that's also on our reference maps. So very, very cool. As you can see, our physical features. Then there's thematic maps, which shows quantitative data. Now, here we see a choropleth map. It's labeled as choropleth. And this uses shades and colors and other patterns to display data on our map. So here, this is for an election. I can't read the stuff. I think the blue one's Obama. But yeah, this is going through electoral votes. Nothing's distorted. Everything is preserved to its original size, but the colors are different to show the majority party in each state. So that's very, very cool. The next one is our dot distribution map, and this just use dots to show data. Each dot has the same value, and we can really track clustering and dispersal with our dot distribution maps. So yeah, and we label an approximate location for each dot to represent a quantity. Then we have a proportional symbol, also known as a graduated symbol map, and these use symbols to display data. Typically, the larger the symbol is, the more of a quantity there is. The smaller the quantity is. And this is population in the United States. So we see big symbols. Sorry, the symbol is a blue circle, and the bigger it is, the bigger the population is. So that's very, very cool. The next is a cartogram, and this distorts the area to represent the value. So here we have a cartogram of the electoral vote number in the United States. So California has the most amount of electoral votes. I think at the time it had 55. So it's going to be the biggest political entity on this map. Florida and Texas have a huge amount of um, electoral votes compared to other states. So they're going to be bigger than others. Mississippi doesn't have that many. It only has like 6. So it's going to be smaller. Um, not Arkansas. Um, Alaska has 3, so it's going to be very, very small. So yeah, a cartogram will distort size to represent the data. And finally is an isoline map, and this uses lines to display data. The closer the lines together, the more similarities there are. The farther apart, the less change, the less similarities there are. This is a topography map, and this is an isoline map because we use lines, but it shows changes in elevation. Elevation is just the distance you are from the sea, and that's a concept you do need to know. And we represent these on our topography maps, also known as isoline maps. All right, here's a map of Texas. It's a choropleth map, and we're going to be looking at clustering and dispersal of population. So I'm going to pull up my handy dandy pen. I'll change the color to like yellow. And we are going to circle a cluster of population and a dispersal of population. So what's a cluster? Well, a cluster is just a grouping together of a phenomenon. So we can circle this as a cluster of population. And then dispersal is the opposite of a cluster. It's going to be the distribution of a phenomenon. It's going to be less in value. So right here, but actually below this can be a dispersal. We see a lighter color over this area compared to up north. We see a darker shade in this area. So this is going to be a cluster. This is going to be a dispersal. All right, now we're going to get into some more spatial patterns. And I have 2 images. Actually, it's one image of 2 different houses. And we're going to do different patterns and features with this image. So we got to find the absolute location of the house on the right, the white house on the right, not the brick one, the one on the right. So the absolute location is the approximate location of something. It could be latitude and longitude, but it could also be something else that is unique to a place. What is unique to this house here? Well, its address. So the absolute location of this house can be its address, which is 711 Teal Avenue in Celebration, Florida. We could use latitude and longitude of the house. However, it's not going to be very specific. I mean, it will be the most specific. It's just going to be a decimal answer, and that takes a lot of work and stuff like that. But for our house sake, we can say the address. Now, if we ask for the city of Celebration, Florida, what are we going to use? Well, a city doesn't technically have an address, so we're going to be using the coordinates of latitude and longitude. Now, we're going to find the relative location. So we need to find the relative location of the brick house to the, I'm going to call it the White House or something like that. Or yeah, we'll just say the brick house to the house on the right. So what is the relative location? Well, we're just going to say that it is west of the house on the right. We're not using anything approximate, and the relative location revolves around the location of that current house, the orientation it is at. Then we have absolute distance, which is the approximate distance from each house to another. So we could say that the absolute distance from the brick house to the house on the right is 7 feet. The property line actually connects. So there's no distance between the properties. So we could say the distance between the properties is 0 feet. But the approximate distance from the house is about 7 feet. Then there's relative distance, which is just the distance without a unit of measurement. We could say steps. So 3 steps from the house to the other. We won't be using our metric or imperial system for this. We're just going to say steps. We could also use distance. We could say 1 second if you'd like. If it takes you 1 second to march 3 steps as well. Then we have absolute direction. And we can use a compass for this. But I'm not going to put a compass up on the screen. I'm going to kind of draw it out. So direction, we're going to use our angle measure. So I could just draw some dots here. And we just got to connect them. I could put this right here. So we're going to connect them. And then we find the angle measure. And the angle measure is actually 180 degrees. So our absolute direction is going to be 180 degrees. And then finally, we have our relative direction, which is just going to be the direction relative to the house. So from left to right, which is what our arrow is showing, the house on the right is going to be to the right. I've been using relative direction this whole time. So our last section of this video is going to be focused on map projections. So when you take a 3D surface like Earth and put it on a 2D surface like a map on paper, there's going to be distortion on the shape, the area, the direction, and the angle as well. Those are all going to be distorted. Okay? So not on every map projection. The Mercator accurately represents the shapes, which is the map projection on the right, but there's something that it distorts. So here we have our Mercator projection. It preserves the shapes, but it doesn't preserve the size of the land masses. So Greenland on this map projection looks really big, looks bigger than Africa, but actually Greenland is smaller than India, which is crazy. Now, if we move India up to where Greenland is, to the poles, where it is majorly distorted, there we go. You can see that it's huge compared to Greenland. It's bigger than Greenland, but it's like that because it's up in the poles. And that's what is distorted on the Mercator projection. Now, every map projection is going to have distortion. The Robinson projection, which I'm not going to show, actually distorts everything, but small amounts of everything. But there's a scale check on the screen. This is free. So yeah, thank you so much for watching. Please subscribe, like the video, it really does help me out. Go check out the next video on geographic data. We'll continue Unit 1 of AP Human. And yeah, I'll see you guys in the next video. Adios.